Hi, everyone. Thanks for coming today. I'm really kind of in awe of how many people have come to hear about R today in Basel. This is really impressive. We have a tight agenda, and we're about 8 minutes over already. We have a packed agenda, so I'm going to rattle very quickly through the introduction. So today, we're first of all going to have a keynote and then a panel session in the first session. Then we'll have parallel sessions after this session as well. So you have a big room here and the small room just up the stairs on the right-hand side. You don't really want to hear me talking any further, so I'll hand you over to the keynote. It's Kirill Mu, who has a large presence and really a legacy in art, and I'm really pleased that he accepted our keynote today. After the keynote, we'll then have a panel session with a number of people who have been involved in the local R community across the years as well, and we'll talk about how R was, where R is now, and where R will be in the future. So thank you again for coming. Hope you enjoy the day, and I'll hand it over to Kirill. Thanks, everyone.
Thank you, Mark. My name is Kirill. I'd like to share my perspective today on the past, present, and future of R. I have a background in computer science. I came to R and to the ecosystem in 2013, give or take a year. In 2018, I, together with Christoph over here, founded Syncra. We are a data science consultancy focusing on R, and now we're a team of a dozen or so. And thanks for the invite. Here we go. Can I get the signal from the laptop, please? Thank you. So R is no longer the replacement for S+. R has its roots in academia, so this explains its openness and curiosity. And by now it has evolved and matured to a full-fledged general purpose language and ecosystem. So what can you do today with R? You can connect to databases, you can query single tables, relational data models, you can display, manipulate tabular data as easy as ever, create packages, deploy packages as easy as ever, and R code actually looks very stylish these days. So just a few of the projects I had the privilege to contribute to in the past 8 years or so. Those were large efforts. I'd like to share a story of a much, much smaller package from the early days. So the purpose was I start in a working directory, I look for a specific file. If it's there, it's good. If not, I go one level up, rinse and repeat. If you're familiar with how Git works on the command line, that's more or less the same thing. I put together some code, I created a package, I submitted it to CRAN. The name is rproj root. Oh my God, who has seen this package? Who is a user? Can I? Wow, okay, so a handful, thank you. Appreciate it, more than I expected. The others don't look at it, it's terrible. It's over-engineered, just like the name. So when I met Jenny Bryan when she was in Zurich, Jenny has a reputation of setting people's labs on fire under mild conditions. So when I met her in Zurich, she said, well, yeah, that's cute, that's nice, but the interface could be much, much simpler. And here we are. And who has seen this package? Wow, okay. Thank you. And this, I think, very nicely illustrates how R works, why I love being here so much. So I was fairly new. I put together some code. I released it. I got feedback from the community from various ends. And yeah, that's what I love about the language, about the ecosystem, and of course, you and I, the community. Now, for the language, I don't have nearly enough time today to talk about all the amazing features that R, the language, gives us. Let me just highlight three parts, three features that I think contribute to a large extent to R's success as a language for data science. So first, R is a functional language at its core. So all the state changes are obvious in your code. If you're into buzzwords, here they are. Immutable data, path by reference, copy and write, pure functions. Functional code is easier to reason about. It's easier to predict what it does. And this is important even if it will run slower than equivalence in other paradigms. The second thing, expressions are first-class objects in R. So you can write something like this. You take the expression, you assign it to a variable, you plug in values for a variable, evaluate it at a later point, also for different variables. This is essential for modeling. This is very useful for plotting and data manipulation and many, many other things that you can use R for. Now, the third point, the data structure, I think, most and maybe only data structure we need, the data frame. So it has been in R from the beginning. The code is as old as R itself. And well, the principle named columns, all the values have the same type. The rows represent data points. And yeah, other systems are adapting and copying this. This is very useful to us. This is very important. Now, I'm biased. I never used SAS. I only briefly had a quick encounter with SPSS. I tried a few other tools, but what really got my attention is this. This is a simple linear model. We capture the model structure, we print it, and we evaluate it. What really got me here is that I didn't know programming languages where you could do that. I started to fall into a deep, deep rabbit hole. I looked into R, I looked into packages, the ecosystem. I have a talent for breaking things, it seems, or maybe exploring limitations. So thankfully, I also had the time to fix the occasional glitch I encountered and scratch the itches that came along the way. So I'm very grateful to everybody who supported me in this journey of exploring R and the ecosystem. So today, when you install Crown, it comes with a handful of recommended packages, but most projects will use other packages installed from repositories like Crown, Bioconductor, RUniverse, GitHub. So Crown is approaching 20,000 packages. We're not quite there yet, but we'll be there, and you see where the trend goes. There are more in the other repositories. So R also has downsides. It is slow, they say. It's memory hungry, they say. And it's easy error in other systems to use all the cores of your computer than it is in R. But that's not that much of a deal, because R is also a great interface language. It's been from the start. We could plug in C, C++, Fortran into R, and now there's Python, there's Julia, there's Rust, there's JavaScript, Go, everything, you name it. So the other thing, you can run tools through their command line interface, process their output. very conveniently and easier with R. So if your favorite machine learning package isn't available in R, chances are you still can use it. So I wanted to walk through 3 big changes in the ecosystem that happened when I was actively using R. So this is a short and incomplete timeline, plier, dplier, and all in vectors. Let's go. So when I started to use R, split, apply, combine was already popular. And I thought this is what programming should feel like. Instead of iterating manually over collections, I tell what to do for each slice or for each item, and it's done. I also heard good things about data tables performance, and I tried it out, but I was so spoiled by the comfort of immutable data that I just thought, well, I replace data frame with data table, and I would get much faster. Split, apply, combine, but this is what happened when I started to use data table. Of course, results were interesting, but not because data table is wrong or anything, it's just the way I used it. So data table is doing things differently from the functional way that many other tools do it in R. So I fell on the nose. Yeah, I got back to my slow but predictable and I think easier to read code. And what's the most important to me when I use these functional paradigms and immutable data, I can rerun parts of the code without worrying about what happened elsewhere. So then came dplier, and with it, the pipe. So response was mixed. Some thought, what do we need that for? Some were confused that filter no longer worked. I hated all my scripts that used plier suddenly really broke because dplier just overrided everything. Now, dplier got traction, the pipe got its own package, and also got into R as a language element. When dplier was developed, also by Romain, hi Romain, glad to see you here, and I joined the team later, it was mostly C++. Now it looks more like this. And how could that be? These 2 packages help with that. Lower-level packages you might have heard of. These packages offer a clean and strict interface for R's objects and vectors, and make it easy for packages like dplier and also others to do less on their own. And so dplier can delegate most of its work to those packages, leaving only a few pieces of C++ code behind. These packages are just like fresh paint and polish over a somewhat rough surface. R does have a legacy, and but all those examples, all those biased examples, I think are to demonstrate how collaboration and community works in R. Now, a big part of our success, I think, is in its openness and its open sourceness. So this is how I imagine working on a closed source software, working with the closed source software looks like. We have an application, we have a use case we want to solve, we go to the manufacturer, purchase a license, we get support and training from maybe the same manufacturer, maybe from third parties, and there's payment involved. And there's also a bit of disconnect. Now, with R, we're all in the same boat. So the software comes free of charge. There's no license. We get excellent literature. We get excellent training material online for free, mostly with an open license. And there is no paid support by the manufacturer, but these people will be hanging out on mailing lists on Stack Overflow and will be glad to help you in making a project a success. We come from diverse backgrounds. We're eager to learn. We're eager to share, to bring us forward. And this language, this ecosystem is, I would argue, simple, so easy to learn that often your script, the script on your computer, becomes a crucial part of the success of your team or your organization. This is production code, if you want it or not, and no matter what your IT department thinks about it. Now, if it's free, if it's that simple, how can it be any good, you might say? Is this a trap? Where's the catch? So I think it's nuanced. It's free as in beer, but also free as in freedom. So you get the software free of charge. You can look into how it works. You can adapt it to your own needs, but there are paid options. So if you want to install R on a server and have an easier time deploying your data science products, there is POSIT. I hear it's used widely in pharma. There are other products like that, all with their own advantages. I'm mentioning POSIT because they also invest a fair share of their revenue into open source. Developing training materials is very, very laborious, so many training offerings will require payment. Now, if that script on your computer becomes a package, that package might be good enough for your own use, but is it good enough for your team? Is it good enough for the package repository of your choice? So this is a niche skill. This is needed rarely, but requires substantial expertise. And there are specialists that can help you with that. And of course, you can bring people on site for developing, improving your data science products, or just for increasing headcount or general support. At Syncra, we do all of this for our clients. And more often than not, the projects are a mix of those topics. And what we do, we contribute back to the community where we can, and we try to fix issues at the root. So this is now. This is what R looks now, or the language, or the community, or the ecosystem. And again, sharing knowledge, sharing resources, a group of persons where everybody is performing at their best and highest with the same language, with the same ecosystem. What about the future? Predictions are hard, especially. So R always had a stable core for as long as I have worked with that, and probably from the very beginnings. Stable as in backwards compatibility, but also remember when we got the new fancy M1 chips, we had the binaries available very soon after that. And I don't expect this to change, and I don't want this to change. This is crucial. This is groundwork, very important for us as the community, for the ecosystem. And I think we should ensure that this gets supported, acknowledged, and appreciated. And this is a challenge. Now, will it be surprising to see more packages? No, it won't. But maybe we should take a look into avoiding duplication of effort and keep our developments or packages discoverable and well documented. I can't wait to have more of a conversation with you, the users, the package developers, the maintainers, the trainers, about what makes R so successful. So let's do more together. Thank you.
Thank you, Kirill. We have time for probably 2 questions, and at the same time, I'd like to bring the panelists up so we'll have a wider discussion. So does anyone have a question for Kirill now? And Sina, Reinhold, Muriel, would you like to start to go to the panel? Sorry, we're rushing of time, so we're trying to transition smoothly. Yeah, question in the audience.
Please wait for the microphone.
Okay.
Sorry.
Thank you. I mean, you don't want to predict the future, but could you maybe say what you think is the biggest issue at the moment that is facing the R ecosystem or language?
That's a question for the panel.
Okay.
So, yeah, I think as long as we survive, we're going to be fine. So, because really, look at us.